Hello friends, myself R.D. Mazen presenting my video on reduction formula revision part 1. Example 1. Evaluate integration from 0 to 2a of x square into square root of 2x minus x square and its integration with respect to x. And therefore, first step is we call that as I. That given integral we call as I. It is integration from 0 to 2a of x square root of 2ax minus x square and its integration with respect to x. We call this as equation 1. This integral or integrand contains a term of the form a minus b, a binomial expression of a minus b. And whenever we have such type of term, we have to put substitution, standard substitution, b is equal to a sine square theta. This is the substitution required, and therefore here a is 2x, b is x square. Therefore x square is equal to a 2ax into sine square theta. 1x get cancelled, we get therefore x is equal to 2a sine square theta as the substitution. And as we are using the substitution, we get the new limit. For x is equals to 0, we get 0 is equal to 2a sine square theta. Dividing by 2a, we get sine square theta is equals to 0. Taking square root, we get sine theta is equals to 0. And therefore, theta is equals to sine inverse of 0. Sine inverse of 0. And the value of sine inverse of 0 is 0. Therefore, lower limit remains same, that is 0. And for x is equals to 2a, we get that x is 2a and that is equals to 2a sine square theta. 2a get cancelled, we get sine square theta as 1, sine theta as 1, taking square root, and therefore theta is equal to sine inverse of 1, and the value of sine inverse of 1 is pi by 2. And therefore substituting these values here in this integral, and therefore that integral I becomes a new limit from 0 to pi by 2. Of x is 2a sine square theta and its square root of 2a into x. The value of x is 2a sine square theta and minus x square. The value of x square is square of this, means it is 2a sine square theta, square of it, into dx. Differentiating this with respect to x, we get value as 4a sine theta. Chain rule, derivative of sine theta is cos theta d theta. And therefore substituting that value here, we get 4a sine theta cos theta d theta. And then simplifying it, from this two term I can take 4a square and sine square theta common, and therefore that integral becomes this is 2a square, means it is 4a square, this 4a, and this is inside the square root 4a square. Square root of that term is 2a. Integration from 0 to pi by 2. This becomes sine theta raised to 4. Square root of sine square theta is sine theta. And this one more sine theta. Therefore it becomes sine square theta. And the remaining term inside the square root is 1 minus sine square theta. And its integration with respect to theta. And therefore we get, if we simplify it, it is 16 to the 32 a square and again a square, it becomes a raised to 4, integration from 0 to pi by 2. This one is sine theta raised to 6 and 1 minus sine square theta is cos theta, cos square theta, and square root of that cos square is cos. This cos and this cos, it becomes cos square theta d theta. We call this equation 2. Then applying that reduction formula, sin theta raised to m cos theta raised to n, outer term as it is, no change, 32 a raised to 4. Here m is 6, n is 2. Therefore, m minus 1 is the first term, that is 6 minus 1 we get 5. Decrease it by 2 we get 3. Again decrease by 1, 2 we get 1. Therefore, these are the terms for sin theta raised to 6. Here n minus 1 we get 1 as the last term and divided by sum of these two, 6 plus 2 we get 8. Subtract 2 every time till we get either 2 or 1 as the last term. Therefore 6, then 4, then 2, last term is 2 into k. Here both m and n are even, therefore we consider the value of k as pi by 2. And then simplifying it, we get this 3 get cancelled, 3 to the 6, 8 for the 32 cancel with this 32, and therefore the remaining terms are 5 a raised to 4 pi whole divided by 2 to the 4 and 4 to the 8 as the answer of the value of that integral. Therefore, here directly it is not in that reduction formula. Therefore, by using the substitution, I have converted it in that third form of reduction formula, sin theta raised to m cos theta raised to n, limit 0 to pi by 2, and then applying that result, we get the value as 5 a raised to 4 pi upon 8. Here what we have to remember, whenever we are having a term of a minus b type in that integral, then substitution is b is equal to a sin square theta, a standard substitution. Using that, we can convert into that reduction formula. Second example, evaluate integral from 0 to infinity of x raised to 2 divided by 1 plus x raised to 6 and that bracket raised to 7 by 2 and its integration with respect to x. Then once again we call that as I. Therefore, let I is equal to integral from 0 to pi by 0 to infinity of x square divided by 1 plus x raised to 6 that raised to 7 by 2 and its integration with respect to x. We call this as equation 1. In the last example, I have discussed the case when it contains a minus b type of a binomial term. Here it is a plus b. And when we have a plus b type of term, the standard substitution is b is equal to a tan square theta. Therefore, comparing this with this, we get b as x raised to 6, a as 1 into tan square theta as a standard substitution. Taking square root on both sides, we get x cube is equal to tan theta as the required substitution. Differentiating this with respect to x, we get derivative as 3x square into dx as derivative of tan theta is secant square theta into d theta. When x is 0, we get 0 equal to tan theta, means theta is equal to tan inverse of 0 and the value is 0. And for x is equal to infinity, we get tan theta is infinity, theta is equal to tan inverse of infinity. And therefore, the value of tan inverse of infinity is pi by 2. Substituting this in that equation 1, we get, therefore that integral I becomes integration from 0 to infinity. Instead of that, new limits are 0 to pi by 2. X square dx, the value of x square dx as 1 by 3 secant square theta d theta whole divided by 1 plus x s to 6, but x s to 6 is tan square theta, and then d theta. Constant term we take outside, limit from 0 to pi by 2, integration from 0 to pi by 2, secant square theta divided by 1 plus tan square. 1 plus tan square is secant square theta, and that bracket raised to 7 by 2, and then its integration with respect to, and therefore simplifying it, we get 1 by 3 integration from 0 to pi by 2. Transferring this term to denominator, it becomes cos. Therefore, it is 1 by secant, nothing but cos. Therefore, it is cos theta raised to 7 and divided by cos square theta integration with respect to theta. And therefore, we get that value as 1 by 3 times integration from 0 to pi by 2 of, subtracting this power, we get resultant term as cos theta raised to 5. Reduction formula, applying that reduction formula for cos theta raised to m, we get that value as 1 by 3 as it is, no change. N minus 1 or m minus 1, 5 minus 1, we get 4 divided by 5. Decreasing by 2, we get 2 divided by 3. Last term is either 2 by 3 or 1 by 2. Here we are getting last term as 2 by 3. We stop here. Into k, here power is odd and therefore we consider the value of k as 1. And then simplifying it, 8, 5 3 is 15, 15 3 is 45. As the value of that integral. Remember this step. Whenever we have a binomial expression in the form of a plus b, then we have to use the substitution b is equal to a tan square theta. Therefore, in the previous I have used b is equal to a sin square theta, as it is containing a minus b type of binomial expression. And for a plus b, it is b is equal to a tan square theta. Example number 3, evaluate integration from 0 to pi sin theta raised to 4 whole divided by 1 plus cos theta bracket square and its integration with respect to theta. We call that as I. Therefore, let that integral as I, integration from 0 to pi sin theta raised to 4 divided by 1 plus cos theta whole square, its integration with respect to theta, we call that equation 1. If you observe here, limits are not in the form of 0 to pi by 2. Limits are 0 to pi. Therefore, we have to convert this limit to 0 to pi by 2 by converting this into half angle. Therefore, we put sin theta as 2 sin theta by 2 into cos of theta by 2 and 1 plus cos theta as 2 cos square theta by 2, and therefore that sin theta raised to 4 whole divided by 1 plus cos theta and its square it becomes, we replace sine theta as 2 sine theta by 2 into cos of theta by 2, that raised to 4 whole divided by 1 plus cos theta. 1 plus cos theta is 2 cos square theta by 2 and its square. Simplifying it further, we get that value as 2 raised to 4 sine theta by 2 raised to 4 cos theta by 2 raised to 4 and whole divided by 2 square and cos theta by 2 raised to 4. So that this to get cancelled, we get 2 raised to 4 divided by 2 raised to 2, it is 2 raised to 2 and sine theta by 2 raised to 4. Therefore, we replace this term by this new term, and therefore that integral, we put the new substitution for theta by 2 as some new variable t, suppose. Then we get the new limits. For theta is equals to 0, we get t is equals to 0. If we put theta as 0, we get t equals to 0. And for theta is equals to pi, we get t is equals to pi by 2. And differentiating this, we get d theta is equals to 2 times dt. Using all this information in that equation 2, we get that equation 2 becomes a new limits from 0 to pi by 2, 2 square and sine t raised to 4 and d theta is 2 dt. Therefore, this is 2 square means 4, 4 to the 8, we take outside the integral sign, integration from 0 to pi by 2, sine t raised to 4 and its integration with respect to t. Applying reduction formula, sine theta raised to n between limit 0 to pi by 2. Here n is 4, and therefore applying that reduction formula, we get n minus 1, that is 3 by n, that is 4. Then subtract 2 from both. 3 minus 2 we get 1 and 4 minus 2 we get 2. Last term is 1 by 2. We stop here, and into k, the value of k is here. As it is even, we consider the value as pi by 2. And therefore if you simplify it, 8 get cancelled, we get 3 pi divided by 2 as answer. Therefore, in this video, I have discussed 3 different examples how we can convert that given problem into a reduction formula, so that we can use that formula to obtain the value of that integral. In my next video, I will discuss the curtaining of Cartesian type. If you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.